Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video, an introduction to integration, is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. In this video, we will be discussing antiderivatives, indefinite integrals, and definite integrals. A function, capital F, is an antiderivative of f on an interval L, provided capital F prime of x is equal to f of x for all x in L. For example, let capital F of x equal x squared. Then capital F prime of x would equal 2x. This means that x squared is an antiderivative of 2x. When studying derivatives, we learned that the derivative of any constant is 0. Let capital F of x equal x squared. So capital F prime of x equals 2x. Then let capital G of x equal x squared plus 3. Capital G prime of x is also equal to 2x. Now let f of x equal 2x. When attempting to find the antiderivative of f, we must consider that any constant added to x squared would satisfy. From this is derived the following theorem. Let capital F be any antiderivative of f on an interval L. Then all antiderivatives of f on L have the form of capital F plus c, where c is an arbitrary constant. So if f of x equals 2x, then capital F of x is equal to x squared plus c. As examples, let's find the antiderivative, capital F of x, for each function f of x. Remembering that we're just working backwards, attempting to determine what function would give us a derivative that equals the given function. F of x is equal to x cubed, so capital F of x is equal to x to the fourth over 4 plus c. F of x is equal to the square root of x. To better see the antiderivative, let us write the function as a rational exponent. F of x is equal to x to the 1/2. Then capital F of x is equal to 2 times x to the 3 over 3 plus c. When we put it back into radical form, it equals 2 times the square root of x cubed over 3 plus c. F of x is equal to e to the x, so capital F of x is equal to e to the x plus c. F of x is equal to 1 over x, so capital F of x is equal to the natural log of x plus c. The notation used to find the antiderivative of a function f is the indefinite integral. The integral of f of x dx using an integral sign. F of x is the integrand, and dx is the variable of integration. We remember the power rule as it relates to differentiation. d dx of x to the n equals nx to the n minus 1. The power rule for indefinite integrals is simply the reverse. The indefinite integral of x to the n dx equals x to the n plus 1 over n plus 1 plus c, where n is not equal to negative 1, is a real number, and c is an arbitrary constant. The following rules apply to indefinite integrals. The constant multiple rule. The integral of a constant times a function is equal to the constant times the integral of the function. This applies for all real number constants. The sum rule. The integral of the sum of two functions is equal to the sum of the integrals of the same two functions. As examples, let's find the following indefinite integrals. The integral of the quantity of 3x to the 5th plus 5x to the 9th dx is equal to 3 times x to the 6th over 6 plus 5 times x to the 10th over 10 plus c, which simplifies to x to the 6th over 2 plus x to the 10th over 2 plus c. The integral of 5x plus 3 quantity squared dx. For this problem, it will be simpler to FOIL out the squared binomial first, which then equals the integral of 25x squared plus 30x plus 9 dx, which equals 25 times x cubed over 3 plus 30 times x squared over 2 plus 9x plus c, which simplifies to 25x cubed over 3 plus 15x squared plus 9x plus c. The integral of 4 times the square root of x minus 4 over the square root of x dx. Here, let's split the integral, move the constants in front of the integral signs as described in the constant multiple rule, and express the roots as exponents. This way we can visualize the exponent rule more easily. Now when we take the integral, we get 4 times 2x to the 3 over 2 over 3 minus 4 times 2x to the 1/2 plus c. When we simplify and return our exponents to radicals, we get 8 times the square root of x cubed over 3 minus 8 times the square root of x plus c. Integrals are more useful though than just reversing a derivative. Integrals were developed as a means of determining the area under a curve. If given straight lines, the area of a bounded shape is easily determined through geometry. The area under a curved line is not so easy. One method is to cut the area into smaller slices that can be more easily measured and added. This method is called a Riemann sum and is expressed as a summation where delta x, or the change in x, represents the width of one rectangular segment, and f of x sub k is the height. If we make more segments with smaller widths, or a smaller delta x, the more accurate the measurement. So we derive the limit as delta approaches 0 of the same Riemann sum. The definite integral is the means of achieving an exact solution to the Riemann sum. We start with the definition. A function f, defined on an interval ab, is integratable on ab if the Riemann sum exists and is unique over all partitions of AB and all choices of x sub k on a partition. This limit is a definite integral of f from a to b, which we write as the integral from a to b of f of x dx. This leads to the fundamental theorem of calculus, which reads, if f is continuous on an interval ab, and capital F is the antiderivative of f on ab, then the integral from a to b of f of x dx equals the antiderivative function f of b minus the antiderivative function f of a. This shorthand notation is used for convenience. Capital F of b minus capital F of a equals capital F of x from a to b. Now let's look at an example and find the area under the curve of x squared on the interval from 1 to 2, as depicted in the graph to the right. First, we let f of x equal x squared, which means we'll be finding the integral from 1 to 2 of x squared dx. The antiderivative of x squared is x cubed over 3, so we are looking for x cubed over 3 from 1 to 2, which is 2 cubed over 3 minus 1 cubed over 3, which equals 8 over 3 minus 1 over 3. This gives us an area under the curve of 7 over 3 square units. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you and good luck with your studies.